Last lesson a couple of days ago, we looked at the areas enclosed by the x-axis. Okay, so we've seen what we need to do. We also looked at what happens when we have symmetry, so in other words, when we have an even or an odd function, and how we can manipulate the expression to be able to get the area where we need them. Okay, so now we're going to have a look at the areas about the y-axis. Alright, so when we calculate the area about the x-axis, the curve equation had y as the subject. Okay, so for example, y equals x squared, y equals x cubed, y equals some function of x. So to calculate the area about the y-axis, the subject of the equation of the curve must be changed to x. So sometimes they'll give you as x equals some function of y, or it'll be as y as a function of x, and you have to get x as subject. Alright, so be able to find the area about the y-axis. So let's look at some examples. Find the area bounded by the curve y equals x squared and the line y equals 3. Alright, so y equals x squared and bounded by the line y equals 3. Okay, so we should all know what y equals x squared looks like. The line y equals 3. Okay, the line that cuts the y-axis at 3. Okay, of course we've got that bound at the origin as well. So we are finding that area there. Okay. So to integrate, we need to first have our x as a function of y. Right, so whatever axis you are in reference to, that needs to be the subject of the equation. Okay, so most of your functions are y equals some function of x, and we're finding the area about the x-axis, that's fine. However, now we're finding the area about the y-axis, we need to change the subject. Okay, so we need to convert y equals x squared to x equals something in terms of y. Okay, so y equals x squared. How do I get x the subject here? Okay, take the square root of both sides. So x is equal to the square root of y. Now, this is a plus minus. So remember, we need to always show that when we're taking the square root. But looking at the graph, which do I need to consider both positive and negative roots? I don't need to. Why? Area in the positive or first quadrant. Okay, so I can neglect the negative root. Alright, so to find the area, it's going to be integral from the endpoint from 3 to 0. So previously we had the endpoints on the x-axis, we now have the endpoints on the y-axis. So the highest on top and the lowest on the bottom of the square root of y, and we're going to integrate that with respect to dy. Okay? Because it's about the y in reference to the y-axis. Right, so integral from 3 to 0 of y, so we use our index clause that we've looked at a couple of times already this topic, so that I can integrate. Okay, so what is the integral of y to the power of half?
3y cubed square root over 2.
Yep, we'll just leave it as fractional form. So we have y half plus 1, which is 3 over 2. Divide by your new power. And this is a definite integral, so in other words, we do have the endpoints of integration, so this I don't need to have the constant of integration from 3 to 0. Okay, so when I divide by a fraction, I multiply by the reciprocal. Okay, so in other words, I'll flip it over, and now I can substitute. Okay, so equals 2 lots of 3 to the power of 3 over 2. You can rewrite this back into root form if you wish. Alright, but I'm leaving it in this because I'm going to use my index clause again. Okay, because I've got a division with the same base. Okay, the endpoint is 0. So again, I can see this whole expression going to be 0 once I substitute in 0. Alright, so I don't need to algebraically show that. I'll just write 0. Alright, save yourself a bit of time. Okay, so we've got 3 over 2 divided by 3 to the power of 3 over 2 divided by 3 to the power of 1. So I use my index law subtraction when I'm dividing. So it'll be 3 over 2 take away 1, which is a half. Okay, so become 2 root 3. So, of course, fractional form of half is the square root. Okay, take away 0, and that's my final answer, unit squared. Okay, is anyone here able to look at that and suggest an alternate way to do that?
Like, why the...
Ooh, you could, yeah, but something more simple, more straightforward. Is there any suggestion on what we've previously done to make that might make a bit?
Make it a square and then integrate the inside.
That's the second time you said square today when you're actually referring to a rectangle. Okay, so Michaela is saying, if I make this the rectangle, and I'll work out the, not 0, okay, I'll work out that value there, I can find the area of that rectangle, right, using my length times breadth, then take away this area under the curve here, that will give me the remaining area over here. Alright, and that's what we're going to be looking at next section, so sum and differences of area. Alright, so good to see you're seeing it now when I ask the question. Alright, B. Alright, so find the area enclosed by the curve y equals square root of x. The y-axis and the line y equals 1, y equals 4 about y-axis. Okay, so the axis tells you what you need your equation the subject of. Okay, so we're about the y-axis, we need y the subject. So we need x the subject, the opposite letter. Okay, so whatever the axis, the opposite letter needs to be the subject of the equation. Right, so I need to get x by itself, get x subject. What do I need to do to achieve that? Okay, so we'll do the opposite of square root. So y squared is x. Okay, so you should always sketch the area to be found so that we are not going on either side of the y-axis, because that will change your answer. Alright, does anyone remember what the square root of x looks like? Not quite.
No.
Yes, you forgot.
Oh, exponential? Like a logarithm?
It's like a log, yes. Okay, so if you've forgotten how to some of these graphs look, was that what you were trying to say? No, good. Not good that you were wrong, good that I was right. Alright, so if you've forgotten what a graph looks like, what do you do?
Put it in your calculator and test points.
So table values.
Table values,
Yeah,
that's
yeah, okay. So if you've forgotten what a graph looks like, table values, okay? Make sure you have a representation of what the graph looks like before you try and find the area. Okay? So the bounds, y equals 1 and y equals 4. Okay? So the y-axis 1 and the y-axis 4. Okay? That's the bound. Alright, so you are finding that shaded region between the curve and the y-axis. Alright, so A is equal to the highest bound, take away the lowest bound. Now this needs to be x, the subject, so I need to write y squared, and I'm integrating that with respect to dy. So what Michaela was getting at, this is your sideways parabola, really, isn't it? Okay, x equals y squared, and that's the top half of it. Because we only need the top half because the bounds are in the first quadrant. Alright. Okay, so nice straightforward one for us to integrate. Alright, so substitute in. So equals 4 cubed on 3, take away bracket 1 cubed on 3. Okay, I didn't need to write the cube bit if I know it's going to be 1/3. Okay, 4 cubed,
16 times 4, whatever that is. You went 16 times 6.
same as 2 to the power of 6. So 63 over 3 units squared. And yes, we can simplify it, yes, excellent.
It's 21.
So the exact area for y equals square root of x between the y-axis and the bound y equals 1 and y is 4 is exactly 21 units squared. Alright, let's make a start on the next one. What's next? Right, see. This is the diagram one. Okay, so it's in your notes. Okay, so we've got that bound, y equals 1, and the turning point for y equals 5 take away x squared. We need to find that area there. Right, so which axis are we bounded by? The y, okay. We're not bounded by x at all because we are 1 unit above. Okay, although if you make a clever approach, you might be able to use the integration with respect to x.
You make it y equals 4. No, listen. You move everything up 1. How often do you have to refill those?
Hmm?
How often do you refill?
How often?
You're doing it constantly.
I don't know. We'll work out using our calculus skills, the rate of change, all that sort of stuff, eh? Michaela's. Alright, so I'm going to do this question as what we're under the heading of, okay, which is the area about the y-axis. If you want to have a go at trying to find it elsewhere, okay, you can do it. But what can you tell me about the shape?
It's symmetrical.
Symmetrical, parabola, which is symmetrical. Okay, so really, just need to find half of it, then double it, don't I?
Yeah.
Okay, because I need to have x as subject. Okay, so y is 5 take away x squared. So x squared is going to be 5 take away y, swapping it around. Then x is going to be plus or minus the square root of 5 take away y. Now, due to symmetry, and remember you are on the positive y side and the negative y side. If you substitute 5 and 1 for that, you're going to get 0 because you're on either side of the axis. Okay, so what you need to do is find it for one side, and I'm going to do the positive one, and then double it. Okay. Alright, so equals the square root of 5 take away y due to symmetry. Sorry, 2 lots of. Okay, between 1 and 5. Okay, so area is the integral from 5 to 1. So I can put the 2 right at the very front there. Okay, because I'm multiplying by a constant number, so the 2 can go out the front. 5 minus y to the power of a half. And that's the other reason why I wanted to do it this way, because it will check that you can integrate that from our previous lesson. Okay, how do we integrate this?
5.
5 minus y, what will we normally do with the power?
Plus 1.
Add 1 to the power. Divide by your new power. What else do I need to do?
Add the 5.
The 5.
5. No, 1, because it's y. It's directly y. I don't know.
What? Close bracket and put 5 and 1 on the end.
Sorry?
Close bracket.
No, there's something on the bottom. I think it's the 5. It's the 5, isn't
2
it?
times 9.
It's the 5.
What did you say before?
Close the bracket and put the 5 and the 1 on the end.
It's
One more thing I need to do.
1. Because put in the coefficient of y.
Yeah, which is?
Like negative 1. Ah, got it.
Multiply by the derivative of what's inside the bracket. Okay? And the minus sign. Alright? Which is crucial. Okay, so I can leave the 2 out the front because the real is a factor of both of them. From the bound 5 to 1. Okay, 2. Now the first one. 5 take away 5, which is 0. 0 to the power of 3 over 2 still 0. Okay, so I know the first term is going to give me a 0. Alright, take away, open bracket, 5 take away 1, so it'll be 4 to the power of 3 over 2, all over 3 over 2 times negative 1. And that is why we need to keep the signs consistent, because they will cancel eventually, so that you have a positive area. Okay, so it's really 2 lots of 4 to the 3 over 2 times 2 over 3. Okay, so we're dividing by fraction. My negative signs have been cancelled because there's 2 of them. So what is 4 to the power of 3?
8 over 3. Wait.
Yeah, before we get there.
So 2 square root 4 to the power of
2 square root.
4 to the power of 3.
Are you saying write this back in the third form?
3. Yeah, but you can't, 2 won't be part of it, will it?
This 2?
No, the other one. That one
Well,
will
you
be
can
separate.
use it eventually. What is 4 to the power of 3?
Oh,
32?
64?
64, square root of 64.
12. 8. I was just testing those on.
General maths down there.
Something like that.
Alright, 2 lots of, what was it, square root of 64, which is 8 times 2 over 3. So 8 times 2 times 2, 8 4, which is 32 over 3. So that's one approach. You can do what you want as long as you get the same answer. Okay? Units. Unit squared.
We also need a year for half the extension lesson.
It's recording. I got it. I know what I missed. I get what I missed.
Do you really?
Okay, last one. Actually, I won't do that last example. I'll move on to some differences. Alright, so that is exercise. I won't do the last one just so I can get to start the next one. 3.7.